everyone's comfortable. Right, let's get started. Let me introduce myself. My name's Mr. Soper. If I was teaching, James is fine in here because we're here as part of something called Maths Week. Right, across the whole of Ireland this week, adults and children are doing activities based around maths. Teachers, I need you to do me a favour. Would you all just close your eyes just for 1 minute? Just close your eyes. Kids, this is just between you and me, okay? The teachers aren't looking. I just want a little show of hands. Hands up if you enjoy maths. Just be honest. Good. Put your hands down. Again, the teachers aren't looking. Don't worry. Put your hands up if you think you can't do maths. You don't like maths. You don't. Oh, good. That's a nice low number. Right. Put your hands down. Put your hands up if you don't think your brain does maths. If you don't have a maths brain or anything. I'm impressed. Right. Put your hands down. Teachers, thanks very much. You can open your eyes again. I think I'm going to have an easy job here. Everybody seems to be really quite positive about maths, which I really enjoy. I'm here to tell you this. This amazing machine that's between your ears, in your head, is the most amazing machine in the universe. And every single one of us can do maths. When I say maths, most people start to think about this. They think of squared paper, they think of pencils, and they think of sums. Yes, that is maths. Yes, and we have to do that. But I'm here to tell you that there's so much more to maths than that. You might recognise this chap off the telly. He's called Marcus de Soper. He's a professor of maths in Cambridge University. He's put it beautifully. He says this: maths is not just sums and times tables. We have to do those, but it's not just that. He says it's the language of the universe and one we can all learn to speak. Right. Psychologists study behaviour and mental processes. We do a ton of maths, okay? When we're collecting data, when we're coming up with new experiments, when we're analysing and doing statistics, when we're graphing everything, so we're trying to find out everything that's going on, there's a huge amount of maths in psychology. But what we also do is we study how you lot do maths. We can use maths to describe the brain. I'm going to ask everybody a question. If you know the answer, just put your hands up. Don't confer. I want to know what you think. What animal on our planet do you think has the biggest brain? Just put your hands up if you think you've got an answer. Thank you for not shouting out. We'll give everybody a chance to think. Let me give you a clue. It swims in the ocean. Look at what your EQ jumps up to. 7.6. Right. Our brains are absolutely massive for the size of our bodies. Right, we can use maths to describe your own brain. Think about your own brain. Rubbish at. The brain is brilliant at many things, but it's rubbish at big numbers. We're going to go from 1,000, and we're going to go up to 1 million. You've got to count to 1 million, one every single second. Right, you know what to do. You've got 10 seconds. Chat to the person next to you. Don't know, don't worry, let me give you the answer. If you wanted to count up to 1 million, it would take you 12 whole days. Isn't that a huge jump? Our brains are rubbish at working out great big numbers. Okay, you know where we're going with this? 1 billion. Quick, you've got 10 seconds. Check with the person next to you. Roughly, it would take you 30 years to count to 1 billion. That is a bonkers number. So we'll make the maths easy. 86 times 30. To count all of the neurons in your brain, it would take 2,580 years. Oh my word. Right, let's look at it another way. If I could take all of the neurons from this young lady's head, as we've taken her skull off already, and lay them down on the table, one by one, remembering that each neuron is thinner than a sheet of paper. Okay, 86 billion. How far do you think this line of neurons would stretch? I'll just take 3 answers. Yes, go on at the very back. How far?
About twice around the Earth.
Twice around the Earth? Twice around the Earth. Do you know that's a brilliant guess? The only thing wrong with it is it's not far enough. You're so close, I'll just say. If you wanted to line up all of the neurons in your head, it would actually go 4 times around the Earth. In every single person in his heads. You've got the most amazing machines between your ears. There's not a single person in here with this amazing machine can't do maths. Right, we've used maths and all sorts of other technology to make some amazing machines. Back in the day, when I was looking at brains, if I wanted to study somebody's brain, I had to wait for the person to die, hope they'd give me permission that I could look at their brain. I then needed to take their brain, fix it in chemicals, and then basically take slices of it on a bacon slicer to see if I could work out what was going on. We don't need to do that anymore. We've got these amazing machines that allow us to see what the brain's doing as it works. Thus, that there are three main areas that have been specially evolved in your brain to do maths. Why would our brains do maths? Why do we even do maths? Well, if we went back 6 million years, we'd get back to the point in the evolutionary tree where we were all evolved from all of the apes, all of the chimpanzees, all of the monkeys. We would come back to a common ancestor. And we know our common ancestor would have done maths. This is a chimpanzee in a Japanese laboratory. And what this chimp has learned to do, look at this. Very accurately, he's able to count up. Now, most of the teachers in here would say, well, that's not really maths, is it? All he's doing is ordering. He's recognised what the symbols are. He's not really doing anything too impressive there. Right, we'll check this out. Right, this definitely is maths, because what he's able to do is to work out the spatial relationships, the geometry of where all of these different things are. And he's not just sequencing, he's putting all sorts of things. Right, this is impressive. Do you want to know how difficult this is? Do you want to try it? Right, this is exactly the test. This is the exact same time that chimpanzee had to do the test. Are you ready? What, too fast? Right, so why are the chimps able to do this? Why were we perhaps able to do this 6 million years ago? Well, if you think about it from an evolution point of view, this would have been very useful. What you need to be able to do is find food and avoid predators to do it. Right, maths is not sums. Sometimes it is, but not always. Maths are tools for survival. The tools that this guy was using was not times tables, charts like this. He was spotting patterns. He had to plan. He had to invent. And the very same skills that he was using are the very same skills that you use when you're doing maths today. We come from a long line. These exact same skills allow us now to program computers or to organise our lives. Right, we're all doing it innately. Let me give you an example. Symmetry. Has anybody ever thought, why? What's so important about symmetry? It's not just so that your teachers can give you a test and you can find out whether you can find out the lines of symmetry. It's because this is hardwired into our brains. I can prove it to you even more. I can make you see something that doesn't exist. I can make a triangle appear on this screen that isn't there, and everybody in this room will see it, just using this bit of your brain. I absolutely promise there is nothing there. If we measured all of those little pixels, they're exactly the same, but you see a triangle because you perceive of these shapes as being incomplete. You've got a sense in your brain of symmetricalness. If I show you these shapes, which are symmetrical here, you don't see a white square because you perceive of these as being complete. All I need to do to make you see a white square is to stop these being symmetrical.
Oh my God.
All of a sudden, you see a white square. I absolutely promise it's not there, it's just your brain. Right, what about number? Number. We spend an awful lot of time at school being worried about these squiggles here. I'm showing you this slide to show you that the actual squiggle that we make to represent the number really isn't important. Okay, if you were born in a different country, if you were born in a different century, you'd be using different squiggles to represent your number. What's much more important with numbers is actually the sense of number. Can you tell the difference between things? Can you move things into sets? Can you work out if things have changed? That's what we really mean by a sense of number. And we've worked out with babies as young as 6 months, they can tell the difference between 10 and 20 dots. Why do we need to know? Why have we got this innate sense of number? Well, again, it's just like our chimp friends, isn't it? If you come across another tribe of people, you need to know, are there more of them than us? Do we need to fight or do we need to flight? Which tree's got the most fruit? What's the best place to go and find? What time of year is it? So we've got this sense of a number. Why is maths hard for some people? At the start of the show, some people put their hands up and they said, oh, I can't do maths. I can't do maths. Well, let me tell you about two things as a reason why you might find maths hard. Don't let your brain trick you into not learning. Right, the other time maths is hard is when we misunderstand how the brain works. A perfect example of this is memory. Just trying to put that into your brain as a string of figures is almost impossible. So, find the patterns. Right, we can do better maths, we can do better studying if we understand how the brain works. Imagine getting a rectangle, fold it in half, yes? Or a square, fold it in half, you get a nice triangle, don't you? So imagine it as a bit of paper that can fold like this. Oh, that makes sense, doesn't it? Right, there isn't a single person in this room that doesn't know how to work out the area of this shape. We've done that forever, yes? This makes sense. Times the base by the height. So if you think about the triangle as being a piece of paper folded in half, how do you find out the area of a triangle? Imagine unfolding it. Imagine it like a piece of paper. Unfold it. Then it becomes a four-sided, regular shape. Yeah. Work out the area of that. Then you just need to half it. And you know, when I saw that, I was like, of course. It's not half base times height. It's not some sort of spell I can't remember. It's just the base times the height, because it's like a rectangle or a square halved. Right? I'll never forget that because I came up with my own explanation. So that's the best way to get things to stick into your head. Also, this is important, interleaved study. You haven't actually put it into your long-term memory. What we should be doing, teachers, this is really effective, we should do the top half of this page, and then the questions that everybody did at the end should be from a couple of pages back. Stuff that we did the week before. Right? And the two most effective ways to study, I'll leave you with these, is this. Spread out your learning. I know this is a cliche, but psychologists have got a term for what every student does. We call it the scalloped profile. Okay. The last one is this. Instead of just generating explanations, see if you can make those explanations into a question, write them down somewhere, and then come back and test yourself. This thing here is absolutely spectacular. There wasn't many people in here at the start, which is really good. Nobody really put their hands up and said they were bad at maths, and that's great, because nobody is. We wouldn't be here if we were bad at maths. There were people here that thought, oh, I can't do maths. Right, if you ever find yourself saying that phrase, oh, I can't do that, think about the dog in the box. Maybe you just had a couple of knockbacks, yes? It wasn't your fault, you didn't really get the idea. That doesn't mean you can't do it. Don't be like the dog in the box. Don't just lie down. Go and get another explanation. Come back to it after a cup of tea. The last thing is, there's not a single person in here that should now be in any doubt. Everybody has got a brain that can do maths. It's got 86 billion neurons in it. It's huge compared to the rest of the animal kingdom. But not only that, there are 3 sections in your brain that are specially designed to do all of this stuff. So, like I say, if you take anything away from the show, is that there's no excuses. Everybody's brain can do maths. And hopefully, knowing a little bit about the brain is going to make us all a better mathematician. Yeah.